There are over 290 known moons in our solar system. Most people can name one, maybe two, but scattered across the orbits of the outer planets are worlds so bizarre, so scientifically improbable, and so completely unlike anything in the textbooks that they have forced astronomers to rewrite entire chapters of planetary science. One moon has an ocean that may be older than Earth itself. One has lakes and rivers of liquid methane and a nitrogen atmosphere so thick you could strap wings to your arms and fly. One is actively tearing itself apart under the gravitational grip of its host planet, and one is a captured asteroid so irregular in shape that it tumbles chaotically through space without a stable rotation axis, making it the most disoriented object in the known solar system. These are not edge cases. These are the moons that tell us more about the possibility of life elsewhere and the strangeness of the universe than almost anything else we have found. Welcome to Space Review. Subscribe and hit the bell because we cover the corners of the solar system that most channels never reach. Start with Titan, Saturn's largest moon, and the second largest moon in the entire solar system. Titan is larger than the planet Mercury. It has a dense nitrogen atmosphere, roughly 1.5 times the pressure of Earth's at sea level. It has weather. It has seasons. It has a hydrological cycle, meaning liquid evaporates, forms clouds, and rains back down onto the surface, just like Earth. The difference is that the liquid is not water. It is methane and ethane, hydrocarbons that flow across Titan's surface in rivers, pool into lakes, and fill seas near the poles. The Cassini spacecraft mapped Titan's northern hemisphere in detail and found seas of liquid methane larger than the Great Lakes of North America. The largest, called Kraken Mare, covers an area bigger than the Caspian Sea. Standing on Titan's surface, you would see an orange haze from the thick atmospheric chemistry, feel a gentle gravity slightly weaker than the moon's, and hear, if sound could carry, the methane rain tapping against a landscape of water ice as hard as rock in Titan's -179°C cold. NASA's Dragonfly mission, a rotorcraft lander, is currently on its way to Titan and is scheduled to arrive in 2034. It will fly between landing sites, covering more ground than any previous planetary mission, and search for complex organic chemistry that could inform our understanding of how life's building blocks form. On Titan, organic chemistry happens at scales we have never seen anywhere else in the solar system, and what Dragonfly finds may redefine what we consider a habitable environment. Europa, one of Jupiter's 4 large moons, looks deceptively simple from a distance. A smooth, pale sphere crossed by reddish-brown lines. But those lines are fractures in a shell of water ice, covering a global ocean that contains, by current estimates, roughly twice as much liquid water as all of Earth's oceans combined. That ocean has likely existed for billions of years, kept liquid not by sunlight, but by tidal forces, generated as Europa is squeezed and stretched by Jupiter's immense gravity on every orbit. Beneath that ice, the ocean floor is almost certainly in contact with a rocky seafloor, and the tidal heating that keeps the water liquid likely drives hydrothermal activity there. Hydrothermal vents on Earth's ocean floor host entire ecosystems in total darkness. The same logic applies to Europa's hidden ocean, and scientists consider it one of the most compelling places in the solar system to search for life. NASA's Europa Clipper, launched in 2024, is on its way there now. If Europa is the most promising moon for life, Io is the least. Io is Jupiter's innermost large moon, and it is in the grip of a gravitational tug-of-war between Jupiter and the other Galilean moons that generates extraordinary tidal heating in its interior. The result is the most volcanically active world in the solar system, by an enormous margin. Io has over 400 active volcanoes. It continuously resurfaces itself with lava, wiping out craters almost as fast as they form. Its surface is painted in yellows, reds, and whites from sulfur and sulfur dioxide deposits, making it look less like a moon and more like a diseased eye. Plumes from Io's largest volcanoes reach hundreds of kilometers into space, and material ejected from Io forms a plasma torus, a ring of charged particles that encircles Jupiter and influences the radiation environment of the entire Jovian system. Io is not a candidate for life. It is a demonstration of what tidal heating can do to a small world in the grip of a giant planet, and it serves as a reference point for understanding how similar forces might drive more gentle heating on Europa and other ocean worlds. Neptune has one large moon, Triton, and Triton is deeply wrong in a way that tells an important story about the outer solar system. Every other large moon in the solar system orbits its planet in the same direction the planet rotates. Triton orbits Neptune backwards. It is the only large moon in the solar system with a retrograde orbit, meaning it travels in the opposite direction of Neptune's spin. This is almost impossible to explain if Triton formed alongside Neptune. The only explanation that makes physical sense is that Triton did not form here at all. It was captured, a wandering Kuiper Belt object pulled into Neptune's gravity at some point in the early solar system's history. It is, in essence, a refugee from the outer reaches of the solar system, now locked in a decaying orbit that will eventually bring it close enough to Neptune that tidal forces will tear it apart, scattering debris into a ring system that may rival Saturn's in spectacle. That will happen in roughly 3.6 billion years. Triton also has active geysers. The Voyager 2 flyby in 1989 detected dark plumes erupting from its surface, driven by nitrogen gas, heated by the sun's faint warmth, and escaping through vents in the ice. A captured Kuiper Belt object, orbiting backwards, slowly dying, with geysers on its surface. Triton is one of the most layered stories in the solar system. The moons of our solar system are not afterthoughts. They are worlds in their own right, each one shaped by a different set of forces, each one holding a different piece of the puzzle of how planetary systems form, evolve, and potentially generate life. Titan has organic chemistry on a planetary scale. Europa hides an ocean that may have been habitable for longer than life has existed on Earth. Io shows what raw tidal energy can do to a rocky world. Triton tells the story of capture, migration, and eventual destruction. And there are over 290 of them. We have visited a handful closely. The rest are still waiting, each one almost certainly stranger than we expect. Which moon do you think is the most likely to surprise us next? Drop it in the comments. Share this with someone who thinks moons are boring, and subscribe to Space Review, because the solar system keeps getting stranger the closer we look.